Okay, we've kind of run into this situation already, but I'm going to kind of go over it again. While I'm at it, I'll go over the problem of the day while we're at it. But we haven't got a power of a power. What I could do, though, is I could always reduce this fraction on the inside first. So I kind of like to do that because it makes my numbers a little bit smaller, or variables. So here, x to the fourth means I've got x written out 4 times. Okay, x to the seventh means that I'm going to have that written out 7 times. Okay, well, I'm only going to write out the first 4, and I'm going to put x to the third power. Because when I take out 4 from top and bottom, that x to the seventh becomes x to the third. So then y squared gets cubed. So I got y to the second times y to the second times y to the second 3 times, because that cubed. And I've got x to the third times x to the third times x to the third, because that's 3 times, because of the third power. And on my numerator, I've got a total of 6 y's. Now, I could have just taken 2 times 3 to get 6. And then on the bottom, I've got 3 here, 3 here, and 3 here, so a grand total of 9. Or I could have taken 3 times 3 to get x to the 9th. So there you go. What this section talks about is negative exponents and 0 exponents. Okay, and what we're trying to do is get this such that there is no negative exponents and there's no 0 exponents left in our expression. Okay, so let's start off with going over our rules that we've got so far. Again, when I'm multiplying here and I've got the same base, the trick is that I can take the exponents and add them together. My quotient power, again, when I'm dividing and they've got the same base. So here that was multiplication, here that's division. I can take and subtract the exponents. And when I've got a power raised to another power, so you got these parentheses, another power, I can take and multiply those exponents. So those are some exponent rules we've got so far. We're just going to add a couple more to it. So grab a calculator and figure these out, or just do repeated multiplication. But we've got 2 to the 5th power, which is going to be, hold on here, 32. To the 4th power, which is 16. 2 to the 3rd power, which is 8. 2 squared is 4. 2 to the 1st power is 2. So if you notice, I'm decreasing by dividing by 2, right? So if that's the case, what do you think it's going to be when I take 2 divided by 2 to get to 2 to the 0 power? Oh, 1. Okay, so 5 to the 10th, or 10 to the 5th power, excuse me. Oh, I'm missing a 0. I'm going to move my comma over. Okay. By the way, it's just the exponent tells you how many zeros there should be. But if you notice here, we're just decreasing by 10. So if I take 10 divided by 10, I get 1 again. Okay. 10 to the negative 1st power. Now, your calculator is going to spit that out as a decimal, and that's fine. We can go that way. But notice how that's 0.5 or 1/2. It's not a negative number. It's just a decimal number. So 2 to the negative 2nd power is negative 0.25 or 1/4. 2 to the negative 3rd is 0.125 or 1/8. Okay, so negative exponents don't mean negative numbers, they just mean fraction numbers. Okay, so along with the 0 exponents, so notice these two. 2 to the 0 power was 1, 10 to the 0 power 1. The 0 exponent rule is that anything to the 0 power is 1. Okay, and the negative exponent is a little bit tricky. There's a reciprocal rule to it, whatever. But what I say is any negative exponent on the top goes down. And what I mean by up and down is top of the fraction and bottom of the fraction, and becomes positive. So what I mean by that is if I've got 2 to the negative 2nd power, I'll make that a fraction. That's going to go to the bottom and become 2 to the 2nd power. So 1/4. Okay, so if I go any negative exponent on the bottom, it's going to go up and become positive. So here's an example. If I've got 1 over 2 to the negative first, that's going to come up to the top of the fraction, become 2 to the positive first power, so it becomes 2. Okay. Again, there's a reciprocal way of doing that, but that's kind of the pattern, the little way to think. It's basically, if I've got a negative exponent, it moves downstairs. So 1 over k to the 4th. Any negative exponent moves upstairs. Okay, so y to the 6. You could put over 1, but it's still just y to the 6. So there's my final answer. There's my final answer. Be careful. Okay, I'm going to make this over a fraction, but it's only the b and only the c that move. And the reason why it's only those two is because they're the only ones with a negative exponent. So this a to the 8th power isn't going to go anywhere. It's going to stay on the numerator because it has a positive exponent. It's this b to the 3rd that moves down and c to the 6th that moves down. Okay. It's not negative signs. This is fine. It's going to be negative 5 in the numerator. So I always make these in fractions. It's just the m that moves down because it's got a negative exponent. So m to the 3rd, n to the 9th. Looks like a lot of mumbo jumbo here, but notice that it's to the 0 power. So everything to the 0 power is 1. Okay, I could do this. I could move this fraction down, go f to the 5th over f to the 8th. Now if I write all 5 f's, there's 5 on the top, so f times f times f times f times f. Do the same thing on the bottom, but do it 8 times. You get the idea. I got 5 that will cancel out, and we got f to the 3rd left over. So 1 over f to the 3rd. I got a times a right here. I got a times a times a, basically 6 times. So if I've got 2 of them here, 6 over there, I got a to the 8th. Okay. I could take and move this down to the bottom, but that stays on the top. B to the 3rd, b to the 3rd, they're going to cancel out, so you're left with a to the 8th. Okay. 3 to the 0 power, just the top part's going to become 1. These two are both negative exponents, so they're going to move up. So they're now up on the numerator, so I've got 1 t to the 2nd, t to the 4th, which leaves me with t to the 6th, because I got 2 here, 4 here. Negative 2 to the 3rd power. Okay, so power of a power, I'm going to go negative 2 times negative 2 times negative 2, that's going to give me negative 8. V to the 2nd times v to the 2nd times v to the 2nd is going to be v to the, sorry, not 8th, that'd be to the 6th. Okay, this piece right here, it's to the 0 power, so that piece is going to turn to 1. And I got 4 and v to the 9th. So the big numbers I can just multiply because we're multiplying here. So negative 8 times positive 1 times positive 4, negative 32. V to the 6 over v to the 9th. I've got 6 v's in the top that I can take away, 6 v's from the bottom, and I'm left with 3 v's in the bottom. So negative 3 over v to the 3rd. Okay. A little bit more complex. So here I'll kind of go through it real quick, but basically I'm just going to move all my negative exponents first. So that's going to go up, that's going to go down. P's stay on the top, so I got p to the 7th on the top. I got n to the 8th on the top now because that moved up. I've got m to the 2nd, m to the 4th, n to the 12th, and a positive p. So take out 8 here, take out 8 here, and I'm left with 4. take out 1 here, take out 1 there, I'm left with 6. So p to the 6th on the numerator. There's 2 here, 4 there, so m to the 6th and n to the 4th. Okay, this is the only thing that's being raised to the 0 power, so it's 3 times 1. That's going to move up to the top. So I got 3t to the 4th. Okay. 3 to the negative 2 power. 4 to the negative 2 power. That's going to move up. That's going to move down. So I got 4 squared over 3 squared, or 16 over 9. Okay, 4 to the negative 3rd, m to the negative 24th, n to the negative 12th, over p to the positive 9th. And what I did is I just multiplied all my exponents together. So the top parts are all going to move down, the bottom one's going to stay put, and that's going to leave me with a 4 to the 3rd, m to the 24th, n to the 12th, p to the 9th. And I got to put a 1 there to kind of hold that spot. So 1 over 4 to the 3rd, which is 64, m to the 24th, n to the 12th, p to the 9th. Okay, so remember, negative exponents are just going to move up and down. And 0 exponents are always 1. Okay. Kind of use the fraction idea there, but hopefully this helps out. You can kind of rewind it or go really slow to kind of look through what I did here, and we can practice again a little bit tomorrow.